it's actually fairly easy to use in my mind. So it's actually kind of the best kind of libraries. All the complexity is taken on by a few people who actually implement it, and you get a hopefully nice and reasonably easy to use interface. Okay, so the objective I have for the talk is create a basic HTTP server. It will be massive light. What it does is it gets requests and but that works and does it asynchronously. It will be single-threaded. I don't like threads for something simple. Why would I have threads in an application if it is not really CD-bound? I want to use the sender receiver framework. He's really worried about not getting the audio. I'll tell you, another microphone over here. Okay? And it will use a minimalistic sender receiver networking interface. Most of the sender receiver stuff I'm showing is kind of proposed. The components I'm using do not use the standard interface in all cases because they were just finished last week. And when I tried it earlier, I wanted to use my implementation for those because we think the new stuff is implemented, but it didn't mesh together, and I didn't figure out what was wrong. In the implementation. The basic design, as one would think, is you have a main which runs an event loop. You don't see the loop, it's just inside a context. It uses async scope or something like an async scope for outsending work. So it's basically, when you have async things, it's kind of, well, similar to a function which is running, which just happens to be suspended at the moment. And while there's life, you need to hold on to that. And async scope is basically a container for these asynchronous things. And the idea is basically there's initial work put in. This is accepting incoming clients. And then each client just gets another element and into that container sort of thing and executes over there. The thing which is interesting in my mind is there's hardly any allocations from the environment itself. It will be really sloppy and use things like strings and allocate all over the place. But if you don't want to have allocations in your sender-receiver world, that's actually fairly easy to do because none of the algorithms does a lot of allocations. Like the async scope is one of the things which does one allocation every time you get a new client, and then it's set. There's no allocation for new work. I will also use a coroutine. Coroutines under the hood basically do an allocation whenever you create a coroutine, so it's a little bit sloppy, but it can avoid, or if this is just an easy case, if you want to do something different, you can. I will use implementations from the Beeman project. It's kind of so you can get all the source code on these URLs. I will put the result of what I do over here onto probably the Beeman project net as well. The implementation is kind of still in progress. The Beeman project is kind of, or the logo, the famous dragon duck with the and it's named after Beeman, who basically pushed Boost, created Boost. So it's actually quite impressive. And as a legacy, want to push on. Like Boost kind of went some way a little bit off the rails in my mind, and Beeman project tries to get it back onto a thing. And this thing was invented when Beeman was riding the dragon duck. There's a picture. This is Beeman on his steed. This is a link to the stuff, but I will just skip over that and we'll start coding. So, showtime. Oh wait, resources. No, I want to get out of here. Interesting. Okay. So the first thing is we need the code, like the Beeman library, and to get that, you just navigate to the website, and I really start from scratch. Right? I basically don't even have that checked out, because one of the objectives of the Beeman project is to give you the ability to try things out. So here's something which hopefully gets standardized. This is not what I wanted to do, but git clone. Okay, yes, there's that. Let's try to get over that, right? Unique, HTTP, whatever. So the entire Beaman, the project inside Beaman are all set up in a very similar way. You just build something, you get into the repository, and the normal way to build it, which I probably won't use because I'm so used to building just with make. You could build things in general with basically CMake workflow and then one of the presets. And I think over here we got a preset like release, and then it should just build. Okay. Oh, it's a preset. File not found. Okay. That's a little bit disappointing. My stuff works as make files. But it also works with CMake natively. This is actually, my make file is just invoking CMake, and this is at the moment just set up to build Beaman thing, an example. And this is the example I will basically refine. So this was built into build, I think, system non, who knows where that went, non-examples, oops. Examples, and then they're all consistently called. Beaman empty, so it starts off with a hello world. Excellent. I think this is a good start. You can, and at the moment I basically prepared the thing so that I don't spend a lot of time building. It's basically just disabling all the tests and building only one example. Once I'm done with the presentation, I'll restore that to build lots of examples and other Beaman projects to it as well. So if you feel you want to test out one of the standard library proposals, go to the Beaman project, see whether that paper is covered, and you can try it out. And if you try it out and it doesn't work for you, you have things, please tell us. This is actually really useful. The intent is to get early feedback. All right, now back to the thing over here. I want to go with Visual Studio Code, or where did that land me? All right, fine. So I don't want to create a file or any of that. So my little empty, when I claim it's empty, it's not entirely empty. I lie a little bit. I basically have a bunch of headers so that I don't spend putting in headers. I have a few, and this is not the ones I wanted. This is embarrassing. Okay, I go with that anyway. I had hoped that that I actually had things set up to be a little bit customized for Munich, but anyway. Okay, so this obviously doesn't do any networking. So let's start and basically get into the idea. What do we need to do to actually get into creating a little HTTP server? And similar to how ASO works, or in general things work in something asynchronous, there's going to be some kind of context which is basically running a main loop. And what it really does is when I say running, the expectation is most of the time it's actually kind of just sitting there waiting for I/O and for I/O to complete. And it's under the hood using something like POL or KQ or IOU ring. All of these things can work. And this is basically the entity to go and say, this is the thing which is going to run. So let's call that context. And to actually run it, we would eventually go and run it. This is a little bit boring. This doesn't do anything and would immediately finish because it goes, all right, I don't have any work. And if run doesn't have any work, it just finishes. So we want to put some work in there. The immediate idea one could have is to say, right, let's say to actually be a server, we want to accept a connection. So we want to do something maybe along the lines of await a connection. So it's going to be something like async accept. And the sync wait is basically a tool to say, right, this thread will run until the operation is completed. And we stick something in there, and this needs basically, it needs to wait on the server. Here comes a bit which I'm really always flaky about what I need to type exactly over here. Exactly. You get something like an endpoint, you know that. but I never remember where that actually lives, because these are things, if you set up a server, you typically set up the server connection point just once, and then you forget, well, if you're like me, you forget how to actually do that. And so this is a little bit, who knows. I may have to end up actually copying that, because this is really, I will copy that, just because it's boring if you try to figure out this, and it's very similar to what Asio does as well, but I want to go through more or less the entire process. So let's do that and go and say we go and just spy on a previous thing where I did that. This will be kind of a fallback, like these things, kind of nobody remembers that. That's all the 2 lines I need. The rest is or the rest is way more often used. Oops. Capital. Sorry. So this is basically just saying, I don't know, no, maybe I can. But by the way, I see people sitting in the back. Can you read that? Or should I make it bigger?
Size is fine. Just
Yeah, okay. I will try to keep it on the top. And the other thing which I want to say is, if you have suggestions of what else I should do, you go kind of, all right, yeah, that's what you practice. Can you also move outside the realm? I'm kind of okay with some of that. So if you have questions, comments, suggestions, that's perfectly fine. So what that should do is, right, we get a context which runs a loop. We get this any is basically accepting any connection on this local host. I feel confident that I haven't coded things, so if people try to get onto my computer and steal things, I think I'm okay. And then this is just accepting a connection. Let's see what it does, because you all can see that this is probably not going to work, right? Oops. It didn't build what I wanted to build. What did it build? Oh, did I save? I didn't save. This is a problem. And I'm not going to build out of VS Code, because I'm not good at setting VS Code up. And I hate that it doesn't build anything. Okay. I know what to do. This gives me no, it builds only the stuff which I'm going to use, and then this should be fine. Build system non examples. Okay. What?
It's a different location.
I'm in a different location.
Yeah. Unless it's a different folder and not open. You need to open it.
Well, okay, I see. Yes, now I get what's happening. This is embarrassing. This is super embarrassing. Okay, let's copy the code. I had in the past I always just went and opened. Well, I had opened it before where I cloned it, and I saw that VS Code remembers to open that again, but apparently it didn't. Okay, let's see. Open folder. Too many folders. Oh, there, unique. Okay. Do I trust that author? This is me. No. You should not trust me. Nobody should trust me. Nobody should trust themselves either. Okay, examples. Empty. But it should be this looks better. This is also Munich customized. Great. This is good. Okay, so fine. I'm sorry. I just need to quickly type a few things again. Context, and then we had an EX support. Async accept server. Oops. And then over here, all we did, I hope this is better now. All we did was context run, and it's not going to work. That's the important bit. It builds, okay, good. Okay, this is better. So it's now waiting for somebody to connect, and we can connect, and nothing will happen. That's the embarrassing part. And the reason nothing is happening is we open the port, and this synchronous waits until the thing is ready, but the run loop is run on the bottom. So that doesn't work. And this is exactly where, when I say, all right, we need to take the work which is suspended and stick that somewhere and not wait for its completion, because it's completing synchronous, we need to put that elsewhere. And I'm going to use something called demo scope, and call that scope. This is basically a container for work, and we go just and stick things in there and scope the spawn. This is sadly not quite the interface the standard library will use, but like I said, I didn't get that to work. So spawn, despite you may think that may create a thread, there's no thread. No thread, I promise you. Honestly, no thread. But all it does, it basically sets up the, oh, this is the other end, it sets up the async, this thing async accept, to say, all right, basically carry on once you are done, and hold on to the work until the entire work is done. Now the entire work of the async accept is really just we accept something and then it would finish. So if you run that, build and then make, see this is what happens. Oh, really? Code of deleted function. Bloody hell. All right. I will immediately jump into making it a little bit more complicated. I think I know what is going on over there, and I thought I had, well, let's see whether I'm right. Not net. I think, so the scope, because you basically just dump things, and has no idea how to deal with errors, it does not accept completing with errors. It also does not accept completing with a value. So I think this is actually what's happening. It's going to also complete with an arrow. So one thing we can do with, oh, you cannot see that in the back. One thing we can do with the senders, like this guy over here, async accept, is basically something which is called a sender. And the sender is basically just sending results of an operation. And we can chain more work on that, on the back of that. And what I'm going to chain on that is basically two operations, one to turn any response into nothing, and any error into nothing. So basically, let's quickly do that. I hope that works. I didn't look at that earlier. So there's basically some tool called upon error, which takes a function object which turns any error into a success completion. And over here, we could handle errors. I don't want to handle errors. Who is handling errors? Everybody is handling errors in their code. So the sender receiver stuff basically is a little bit like the error completion, where things complete with an error. You have to deal with the error. If there's an error, you cannot chain things together and eventually not deal with the error. So this is a little bit like enforced exceptions. Okay, and then we have a then. I hope this compiles, and then can, in theory, complete with lots of things, and we don't do anything with that either. This goes, no, this parenthesis is right, this one is wrong, this semicolon is wrong as well. Okay, let's go. I hope that works. Oh man. Whew, it does. Okay, great. So now we have something which basically, well, all it does is at the moment waiting for something to accept, and most of the time we'll use the browser and can see that it immediately completes. Earlier you saw that hanging, now it's not hanging, and this guy immediately completed. So we basically did something right. So this is cool. Now that doesn't help us much. And we could try to use sender algorithms to compose our basically our main loop, which is awaiting connections to come in with just senders and sender algorithms, but it's really annoying. It's way easier in my mind to use a coroutine. Now, coroutine, all that amounts to is, I will just do that over here and go, the coroutine is a function. And has everybody used coroutines in C++? Okay, about half the people. The rest doesn't know what a coroutine is, that's fine. So a coroutine is basically looking like a normal function, but it has some core keywords like co-wait, co-yield, or co-return dumped into it. And once you have one of these keywords in your code, in a legal position, it becomes a coroutine. It's an entirely different thing than a function, because everywhere where you have one of these core keywords, the function can stop processing and in many cases resume later. So like you can always stop processing a function by returning, but it's a little bit boring because you cannot get back. With these guys you can get back. So we write a coroutine. The way it works is we basically declare a function and we need to give it a return type. Because I'm not using the standard version, I'm using a little bit of a simplified one, which is also called task. So this is my coroutine type, and the function I'm now writing has a body, and the body is a kind of the coroutine-y thing, but the function itself is actually not really the function we have called. It's more like a factory function for a coroutine entity. So, which by default does nothing until we actually start it. And we're gonna accept the server, that's great. We showed how we can suppress errors and things and handle them. We don't want that. And this we gonna co-await. So it's basically co-awaits the result of the async scope. And then this does not work because this is just a lambda, and spawn takes a sender. To turn this lambda, which returns a coroutine, into a sender, we need to call it. So let's do that. And that's not something awkward, because the compiler will tell us it doesn't know how to get server. Now everybody knows we have a lambda, we could just use a lambda capture, right? Like go over here and capture a lambda. I hope everybody who knows about coroutines moans massively and goes kind of, bloody hell, no, don't do that. And of course there's a problem, because the coroutine function we write over there is actually a factory function. That function goes away together with this capture before the body is even started. So anything in the lambda capture which we access from the body is dead. That is unfortunate, but it's by design, and it's nothing the coroutine can do about. So if you actually want to pass something in, you need to pass it in as an argument, which is a little bit more annoying. So we need to write something like, I will avoid hiding messages and just call it a little bit different, and we pass it in over here. So this is in my use of coroutines, a common pattern that every time I need to capture something, I have to do it. Everything which is part of the argument list or any of the local variables, they're all automatically captured. That's fine, but not the lambda capture. Okay, so this should actually do just the same thing, but it's still a little bit boring because, well, I'm not even going to run that. This is just going to complete. So let's do a little bit more. And we go and say we put a loop around that, and that's now perfectly fine. So we can basically have a loop, and maybe we capture the loop, the things coming back. What it returns is a pair of the connection which came in. So we basically have the pipe and the name of the other endpoint. I think in that order. So it's basically client address. So we should see. Received connection from address. And I will do, just to avoid things not being printed while we don't have them, I will just make sure cout always flushes things. Never do what I'm currently doing in production code. Never. This makes everything really slow, massively slow, because every time something is printed to standard out, it flushes, and this is bad. but because we want to see what happened and I don't want to have partial outputs or something like that, or only output when the buffer is full, I just stick it there. So we get a receive connection, and then maybe we also go and say awaiting a connection. So, and at the moment we don't really do anything with that, we just drop it on the floor. This will change in a moment. Semicolon. Oh yes, there. Oh, and a new line. Phew. I mean, I hope this is everything, but I don't know how people can write things like Python or JavaScript, where you can have all these errors and it only tells you at runtime. I have so many typos and things where the compiler catches me out and goes, no, you cannot put these things together. That's not what you meant to do. Okay, so now we still drop the connections on the floor, but we should actually have as many connections as we want. Can I do these things next to each other? So you can see that every time I do that, we see on the other side, connection came in and went away. Now, so far, everything I've done so far, you can actually do with a synchronous program, because there's nothing asynchronous per se, right? We have only one connection we wait for, and we drop it on the floor. So let's change that. So next thing I want to do is I want to go and say, actually, let's say we create a function and we call that run client. And we basically take the client we have and move that into the function. And then we basically create another function over here, which becomes our task. No, client is misspelled. Yeah. Let's do that right, otherwise it doesn't work either. So, your function run client. Run client, I don't know what it takes. Client. But I know what it's going to return, because I want it to be something which is asynchronous, so it's going to return a task as well. All of the things, whenever I return a task, you don't really need to use a task. You could build that with standard algorithms, although the standard library doesn't provide a looping construct, but one can create one. It's not necessarily hard, but standard library doesn't have it. So over here we could go and say what we really want to do, sort of, is we get things into buffer, and I will be very sloppy. I just read things into fixed size buffer and then co-await something like accepting the async receive from the client, and then to not have to support every buffer type everywhere where we need a buffer. There's a buffer class around that, so that should do that. And then we could maybe go and say received, and say what we received actually. Lifehack, put in what we did. Oh, we didn't actually say how much we received, so let's do let's do a little while loop, size tn. As long as we receive a non-zero size buffer, we do print that. That's nearly a server already. And so basically, we need to go and then we have a city string view request. So the async receive, so it's not async receiver, it's async receive, basically receives the available data. That's quite common, that you basically on a stream thing you just get as much as there is. It doesn't wait until it gets 1,000. You can write an algorithm around that if you want to get a fixed size, but that's not what we want, right? Basically, typically the request will be shorter. In fact, if it is longer, maybe make it a little bit bigger just in case. If the request coming is actually bigger than the buffer, we would have a problem because it doesn't work. A real HTTP server would actually need to go and look at whether the received stuff makes up an actual complete request, and if not, carry on waiting. We will skip all of that. Yes?
Won't it stop at what the buffer class limit, how much can be read? Since it's tied to an array?
Well, the buffer class will go, right, you can read up to 10,000, and then the async receive will say, you read n. And n will be between 0 and 10,000.
So this is still safe, you won't overrun the buffer.
Yes, there's no way to, well, this does not overrun the buffer per se. I'm not going to say there's no way to overrun a buffer, but my library doesn't overrun a buffer, to the best of my knowledge. Who knows, right? So we get n back, so this is what we get back. So we can print what becomes a request eventually, and then max slash n. All right, so we start that. Well, so at the moment we would run client. Run client returns a coroutine. The coroutine is an object which does nothing, so we drop it at the floor at the moment. This is not going to work. So this would actually just disconnect the client. So let's not do that. Instead, what we want to do is something like we want to do a scope spawn thing, and basically go and stick that into that buffer, and it becomes one of the things which the scope basically maintains until it gets done. Which also means we need to get a scope. All right, fine. Let's get the scope. So we need to do the same little dance. We cannot. There's not really a way to basically just do the reference and we can reference everything. You need to name all the things you actually want. Oh, it's called that. Scope. Okay, and this will start it, and now we should have multiple things possibly running. Let's see. If everything were right. No matching function for run client. Yes. I think, no, wait. Run client should not take the client by reference because actually move it in as a R value. Okay, so if you run that, actually I want to get another window so that you can see that I'm actually not making things up and basically secretly have somebody. Oh, it didn't create another window. Okay, so here's the thing running, and here's the window. You see, so telnet that. So now we can connect there. We can see that it is again awaiting another connection. So we could create another connection, but we can also send a request, and we received hello. Which is cool. So far, so good. I mean, we're nearly there with the server. We can. Oh, we don't print anything when we disconnect, so maybe we could do that to see that when I do, what do I need to do? Control this, quit, that you can see actually everything being destroyed as well. How do you do that? Like over here we could go and say, at least client done or something. I want that anyway. So there's a cool little message that you can see when the client is actually going away, and everything can just work concurrently. I'm loving it. And so, okay, doesn't matter whether I type hello correct or not over here, and if I basically control this. If I quit that, then you see the client is done and all the resources get cleaned up. And by the way, as you can see, I don't fuck about with any shared pointers or new and delete or any of this business. This all just objects floating about. Now everybody using coroutines can do that for that matter. Yes?
Can you already connect two clients at the same time?
Okay, let's try. Two clients. Client 1, let's say client 1. You see client 1. Let's see what happens if I get another window over here. Oh, it's already does a eternity thingy. Now I want to go over here. Now I just need to find back the window. One of the windows should say it.
The other sound the right window was just
The other tab in the, oh, this tab, yes. So, client 2, so we have two connections. Client 1 can still talk. We can also go and get rid of the second client which came. Quit is I was going kind of, why does it not save anything on the other one? But there it is. And our client one is still alive. So yes, that works. Right? We could accept multiple clients and we could accept more clients. Okay, now the next step on doing an HTTP request is HTTP. Everybody did HTTP ever at all? Does everybody know how that looks like, right? Yes, okay. So this will be slightly boring and I'm not really good at decoding that. What I found earlier is I actually don't want a view over here for reasons. Actually, I don't know why iString stream doesn't take an string view as a constructor in this implementation.
It's 26.
Oh, we only get that with 26? God. I don't know who goofed that up. Wait, I'm in this long. It's not me. I'm not me. Okay, so we want to, what do we get? We get the method, the URL, and we actually don't really care about the version, but let's decode the version as well. And then we just go, if we decode, we get something which has a method, and a URL, and a version, that should be good enough. And then we go, well, if the method is get, this is, then maybe we do something. And so basically we see requesting, and then the URL we request would be URL. And let's go, and I only deal with the ones I know, right? I basically set up a little bit of files because I know the room is full of hackers. So if I basically went and just read a file and somebody would try it. I think I'm safe. If you're a real hacker, maybe you can plug a hole. If you do, please at least let me know what my problem is. So we go, well, if in files contains the URL, then we're requesting the URL, and then everything else is just kind of, well, we need to get the URL, fine. So you get an, what do? We get an iString, ifstream, fin plus the URL. Well, this is what we get, files of URL. Should be reasonably easy. And then, this is really inefficient. Don't do that in real code, but just to get all the data, we get an out, and basically just go read the file into out, fin.debug. Okay, now we get the file. Then we can basically get the data out. Auto data is out.str. We need that to just figure out how big it is, and then we need to put a header in front of that. I hope everybody remembers that. Like, I will just go and reset out. Okay, you get that, and then we basically write out, how does it work? I need to, first thing I always remember, I'm gonna lie. I will pretend that I'm HTTP 1.1. This is not true. And then I go 200, and I think that's it, no, right? Is that it, what I need on the first line? Actually, I don't know for sure. But next thing I need, at the end of the line, I need an \n/r. And on the next line, I need, sorry?
Other way around.
Other way around? Oh, yes, sorry. Yes. And once I have that, I need to have a content, length, and this is just data.size. And then I need another one of those. And then we pretty much done, right? All we need is another one. We need another one, basically a separator. And after the separator, all what is missing is the data, and there's this one missing, and we call that data. Okay. Unfortunately, I need to get it out again. So auto response. Response is just auto star. And then I do another similar thing. I will not test for error. We can do all of these things and basically keep sending if it doesn't send all of these things. For the small examples, it just works. This is just boring stuff around it. So we basically do another async send in this time to the client, and we do net buffer of response. Okay, assuming this compiles. Does it compile? Oh, it compiles. Brilliant. Okay, I go big. I will try directly with the browser. Why not? Nothing can possibly go wrong, or can it? So we basically running on localhost. Localhost this address. Come on. Woo! Thanks. Yeah, it was a relatively quick way to implement an asynchronous browser, and you can actually see that the that Google is async. No, I don't see that over here. Oh, because I don't. Did I write in a creative client? No, I don't. It actually creates multiple connections and actually gets a file, tries to get the file asynchronously as well. So if you have lots of things, this guy may get 5 connections, and Chrome trying to get 5 things simultaneously. I think we can show that by basically going printing a little bit over here. Like, let's see out new client. And then the thing which is possibly a little bit annoying, a little bit of a problem, because if you have thousands of users which actually do this, is it doesn't surrender the connections. Right? If we are here and we load that, you can see we have at least 2 clients being around, and none of them finished. Which means this just sits there and it takes 2 file descriptors. This machine, I don't know, I think I ran out at about 8,000. So this machine could only serve 4,000 simultaneous clients, which are just sitting there. This is no good.
You're expected to close if it's not a website.
Well, yeah. Well, sure, if I have a WebSocket where I need to keep talking, I don't want to close it. But right, if it just sits there, maybe I want to get rid of that. And one thing which may be interesting, I don't know whether people are interested and we have time, but could be to say maybe impose a timeout and close things after a time, because that may be interesting to see. And by the way, if you have other suggestions, let me know. I'm happy to play with things and riff a bit, right? But timeouts have an interesting aspect to them. And so has anybody implemented timeouts on things? Okay, so some people have. How did you do it? Was it complicated or easy?
It was painful. Yeah.
Painful. Everybody agrees it's painful. I just want to get that message around. So, hail the hero, I will encounter pain, or maybe not. Because here's an idea. How could you implement a timeout? Well, a timeout is really 2 operations, one of them successful. Right? There's one operation which does the business, and another operation which basically completes after time has passed. And if the actual business logic completes, you cancel the timer. If the timer times out, you cancel the other one. Right? So you basically have a mutual cancellation thingy. Easy. Well, we can, if you want me to write the algorithm I'm going to use, I'm not going to do that in 2 hours, but I can show I did it. But basically, what I imagine a timeout would look like, the timeout interface will not be quite that, but is something like we have a duration. And we have a sender, which is basically a generic version of what work we do. And in here we basically do and say, this is unfortunately not a standard library algorithm, so if you want something like that, you need to write it or get it from somebody. Something like when any, and this actually takes however many arguments you want, and basically sits there and completes once one of them is complete. Well, it completes when all of them have completed, but once one of them has completed, goes, this is my result, and I cancel all the others, and I will ignore all the other results. The thing with sender and receivers is, however, the when any does not complete before everything else has gone away. So basically, by the time when any completes, there's no outstanding work anymore because everybody has completed. And this is a general concept of senders. So we do something like when any, and we do something which would look like, well, that's sort of just doing the actual work. I take it as an R value, okay, fine. So I can just move it, that makes it a bit easier. And this is one of our work, and the other work is we do something a little bit more interesting. This is basically resume after duration. And unfortunately, as written with the current setup I have, this does not quite work. The resume after needs to know how to put things into the context, right? So into the I/O context. So it basically takes something which is a scheduler. So we will need a scheduler over here. And to make our setup nice and easy, I also want to make sure that if this guy resumes, I actually resume such that my original loop over here, which basically terminates when we get a size 0, actually terminates. So I basically go and say, if after duration, if this completes, this actually completes with just kind of no argument at all. I go and spin something different at the end. I go and say, okay, then, and if it completes, no arguments, I actually just return a size t of 0. So, and then I go, well, all I need to do now is I need to return that. So the slight caveat with what I'm doing over here is the use of the size 0 is a little bit specific to the application. To set things up to be more general, you need to have a different way to do it, but you can. There can be a general timeout. And even if there's no general timeout, that's pretty much the implementation, except that, well, we also need a scheduler. And this is where the pain comes for me in my mind. Right? So we need a scheduler. All right, so if I need a scheduler in the timeout, well, I'm going to use the timeout right where I wait for data. Okay, so I will co-await the timeout which gets a scheduler. Okay, I don't have that. And let's say 3 seconds and and then our operation. Okay, fine. So this means I need a scheduler over here as well. Okay, so run client. I don't have a scheduler over here either. Oh god. So scheduler or scat. I need to get that as well. Fine. Auto. No, this can be value scat, and then this is the scheduler I'm going to use is just from the context get scheduler. Okay, let's see whether things compile. Fingers crossed. It doesn't. Okay. Type specifier is required for all declarations.
Return type.
Ah, no return type. Yes. Okay. This is a little bit sloppy of me, especially as a return type. Does anybody venture a guess how to write the return of the things? Correct. You spell it out. All those kind of. In fact, you would struggle writing this return type because the types you get out of error messages over here may be lengthy. This guy is probably not that lengthy, but it's probably not short either. So auto is a real thing.
I believe you deleted the line.
Say?
I believe you deleted a while statement.
Oh, I did. I did. This is by accident. All right, sorry. Thanks for pointing that out. This will not quite do the right thing. Okay, cool. Let's try. I mean, this is as much pain as I can bear in programming, so I hope this goes 1, 2, 3, 4. Come on, bastard. Ah! This was more than 3 seconds though. But you can see that it eventually typed out. So the timeout is there. And I think this is actually, this alone, in my mind, is a pretty cool result to go and say, all right, I can compose my sender algorithm. This is not really hard to do. And this does all the necessary cleanup. Maybe it's not the most efficient approach. And it's not the right approach in some sense. For example, if you do something like, if you, the I/O in the back is backed by something like IOU ring, because over there you have actually way more efficient cancellation mechanisms than something like that. And you need to hook into that, so you can write a way more efficient timer based on IOU ring. But the idea would be you actually use timeout, and if somebody recognizes this thing is actually just a timeout on one of the I/O operations, it could actually secretly be turned into, not with the spelling, but if you spell it correctly, it could be secretly turned into, all right, I know what I need to do, and I will hijack the algorithm. Okay, this is as much as I had prepared. Anything else you want to see? Yes? Sorry, where's what? What is a scheduler? Okay, so the scheduler is basically, in this case, a little bit. So, in the sender-receiver world, conceptually, the scheduler is an entity, and this guy implements that, which has a specific interface. The interface is actually really simple. A scheduler is something which, well, simple. The use is really simple. The implementation is annoyingly a little bit not as simple. The entire interface a scheduler has is it has one operation. It's called schedule, and auto schedule pops in sender. And this sender completes wherever you want to schedule things with an empty completion. Over here, I'm actually not using that really. I'm using the scheduler just as a handle to my I/O context. So I'm actually using a different interface. So this is a little bit more fancy scheduler which knows about timing. But conceptually, it's something, a handle to a context, and it has in particular schedule operation. It basically completes wherever you need it to go. You normally don't use schedule directly. You typically use an algorithm like continues on or starts on. These take a scheduler and a sender, and they arrange for the operation you want to run on the right scheduler or complete on the right scheduler. And all of those things makes it actually quite easy to go across different execution contexts without having to code for specific entities. The biggest caveat with the entire sender-receiver stuff, as you might have seen, it's kind of essentially a big expression template. So pretty much all the sender-receiver stuff is gonna sit in some way in a header. There's at the moment only one type erased sender proposed, which happens to be task. So task is a concrete type, so you could basically return a task from your CPP file and stick it into everything else. But the entire sender-receiver mechanism is pretty much an expression template, which is not the fastest to compile. Okay. Anything else?
So right now, all of our functions are unconstrained, right? We used auto everywhere to get them.
You want me to constrain them?
Yeah, just do it like for one function, just so that we saw it. How it
Okay.
looked like.
Okay.
Yeah.
I will use the easy one.
Yeah, of course.
I will use this one. So the first one is a scheduler. Okay. Let's constrain that to be a scheduler. All right. So now it's constrained. The thing is, it actually doesn't really buy you much. These constraints, and they actually are kind of harmful And I will explain that. So what this says is this argument is not a scheduler. The use, or it's not the correct kind of scheduler, the use over here in resume after will not compile and give you a nice error saying, all right, this is not the thing I expect over here. With that, the error now tells you something like didn't find timeout because this thing is not matching these things and gives you a long error message telling you all the reasons why whatever you passed does not match the entity. We unfortunately got the wrong concept. Right? There were people who were violent against the idea that you could say, I have an entity and I say this entity models this concept. Anybody knows a language which does that? Which says this models a concept?
Rust.
Rust, indeed, Rust. And just last week I learned something which blew my mind. I need to share that. So, yeah, you're all too young, but before C++ 11, there was a proposal to create concepts. And this proposal was modeled around you declare what a concept looked like, and functions would allow you to pretty much only do things which are what the concept says it does. And you would need to say for a class that it models a given concept. Again, Rust, right? Now this is in Rust. Rust took a lot of influence from Swift. In particular, this part is taken from Swift. Now, you wouldn't know, but there's an intersection between Swift and the people who did the original concept proposal, was Doug Greger. He went pretty much, once the concepts were ripped out of C++, to Apple to implement Swift. So sometimes we'll go, oh, you can steal ideas. In this case, they really stole the idea. They took it away from us. They took a good idea away from us, put it in Swift, and they got it in Rust. This is upsetting. We had the right concepts in the standard paper, and people insisted to rip it out. And we get this not so great concepts. Because the error messages you get out, despite people saying, oh, concepts create much better error messages, I cannot agree at all with that statement. Okay. But basically, if I want to constrain more, I could also put the center over here, right?
So your suggestion would actually be to leave it unconstrained, even in production code?
If it does not do the right thing, it will not compile. There are a bunch of places where you do want to use concepts, because they actually do allow you to choose between different overloads. Like for choosing between overloads, concepts and requirements are great. To constrain and try to prevent users from actually going into something, I don't think they're that great at all. At least this is my current take, and actually both scheduler and sender try to be a little bit helpful in the sense of they actually have implemented a hacky way of a models declaration. You need to basically, part of this scheduler concept is your class modeling scheduler needs to have a nested type def scheduler concept, which is assigned to one of the scheduler concepts. Currently, there's only scheduler T. So it's basically a models declaration, sort of, but it's a bad models declaration because it doesn't give you all the benefit. All right. I hope I didn't lose everybody on my little rant over here.
I think that was very insightful. I actually have a question from online. So one of our online viewers remarked that the API to this networking library is very similar to ASIO.
It is.
And they were wondering whether you also support other protocols than TCP, like UDP or Unix domain sockets as ASIO does.
Okay, so the networking interface I currently have pretty much does what pretty much does what the networking tier has proposed, and you can use it with datagram sockets as well if you want to. In which case, the sizes and the datagrammy aspect makes more sense. This is, however, an early version of what was proposed. It is in a proposal. And when we discussed that proposal, the networking people went pretty much kind of, yes, that's not quite what we want. So the networking, actually, which I showed over here, is probably going to change dramatically. In case people are interested in what direction that is, there's a standard from the Internet Task Force, AETF, called TAPS. It's not yet standardized, but it basically says, all right, this is how we believe applications should interface networking. I know that there's controversy among IETF people whether TAPS is the right direction to go, and nobody currently really implements TAPS. There's a half-hearted version of TAPS in the Apple API. There are some things. We still think it's actually kind of a reasonable idea. The reason we want to go there is this raw sockets, basically the easiest way I did over here. You may have noticed I typed HTTP. I did not type HTTPS. And actually getting HTTPS to fly is hard. And so everybody would use the unsecured version, and people took issue with that the easiest version is doing the unsecured thing, although we know this is the worst thing ever. It also travels in terms of an IP address. It does not travel in terms of machine names. And to basically get things both secure by default and an easy way to go and put in a name and possibly open multiple connections trying to see, because if you put in a name, like let's say you put in Google.com and you ask DNS what is Google.com pointing to, you don't get one address. You get a whole host of addresses. And the underlying system will go and try multiple of them at the same time to see which one works best. And you get a connection on that one. And to model these things, we need a higher level abstraction than the socket level. And we propose something in, or the plan is to propose something in that space. It will, because I can already hear the online question, will this also support UDP or something like that? And the answer is yes. It also will support unsecured sockets. You basically, the way TAPS works is you say, I want a connection which has these properties. And these properties may be delivered by a protocol or a lower level, or a high level or lower level protocol like QUIC could satisfy things. Different properties could be satisfied by TCP, unencrypted, or UDP. And you basically give these properties, and then the system selects what it can do to satisfy these properties or fail. Okay, I hope I made the person online happy-ish. Anything else? Yes. Run. No, we have time. There's no rush. I think we have time, unless everybody falls asleep.
Is there a way, some sort of fake this value for testing to simulate IO timeouts? Basically, how would you write a unit test for this timeout?
That's an excellent question, and my current implementation doesn't have it. I have a toy implementation which does have it, and is basically the run loop at the lowest level does operate in terms of an interface, and is just using virtual functions. The virtual function it uses are a little bit awkward because I want that interface to be implementable easily on something like our Uring, and as well as on top of POL or KQ and all of these things. I've implemented some of these things, but not all. And in particular, I haven't implemented in the full-blown version a testing API, but yes, you can. I would imagine that actually, depending on your needs, you would have, like what I imagine how the testing interface would look like is not necessarily the way you would imagine it. I don't know whether we will standardize an interface, but I definitely want to have something that you can plug in your implementation of that interface, plugging on top of the run loop, so that you can do testing as well as provide access to future interfaces which we don't know yet.
Yeah, thank you.
That was my question.
But But absolutely, actually implementing, testing things by going and having things to do live is super annoying, right? It's way more reasonable to assume that the lowest level you have tested, and then everything higher level is basically tested via test interface. Oh, Andreas wants to.
If nobody else, then I will just keep asking questions.
Sure.
So I think the one of the most impressive and maybe also a little bit magical lines here is the when any. So I wanted to maybe talk a little bit more about that. So the async receive that we're doing, that is what lands in the sender.
Yes.
Now, when the timeout expires, what happens to that sender?
So basically what when any does, internally when any has a stop source, and you don't really see that in any of the code, all of these things can be cancelled because they basically get a stop source, and actually all the I/O operations register a stop callback or a callback with the token coming from the stop source. So basically, both operations register to say, all right, I want to be cancelled when the stop source gets cancelled. And now all when any does is it basically listens for the first set value completion. It gets a set value completion, and it can switches, requests stop on the stop source, and then basically counts how many outstanding operations there are. Once there's none, it completes. That's all it does, really. If you want to see the code, I can bring it up, it's there. It's kind of, I don't think you have to be scared in any shape or form. Okay, so when any. So, when any looks really simple, it is simple. So over here's the interface. Right? Oh, nobody in the back can see that. Let's try to get it on the top. And it's basically a function call operator. So when any is an object, it's an object primarily so that this allows us to have a hook to replace it. I'm not going to show you how to do that. This gets a little bit mad, but so it gets a list of senders. All this guy does with the senders is package them up into a container. This is actually not interesting. The senders are basically just saying, this is the information I have to run the operation. And the real magic happens when this information is connected with the destination of where to send things to. This is a receiver. We have actually seen lots of senders. We have not seen any receiver. Receivers are basically a generalization of a callback. As basic, roughly speaking, 4 operations, or up. Okay, 4 kinds of operations. Let's go with that. One operation is called getEnv. This is basically to forward environments across multiple receivers. So basically, if you're a chain of operations, you basically at the end where you actually start things, you configure sort of how the rest is going to work, which is actually interesting. You set up the entire sender stuff, and then you configure it from the back. You don't need to configure it from the front. So the getEnv is basically the way to say, all right, I want to get information about the environment I'm living in. This would give you something like a stop source, a stop token, or possibly also something like a scheduler, so you can basically get this information. If that is not there, there's just no information coming with that. And then it has 3 operations which are basically like a callback. There's set stopped, taking no arguments, which says, I tried to do my work, I didn't fail, was asked to stop doing it. This cancellation. It's another failure, no success. It's basically we gave up for whatever reason. There's set error, which gets exactly 1 argument, which is the error, and this says, I failed. That's kind of the exception case. And then there's set value, and set value is the successful, we made some we satisfied our contract, and our contract, whatever our contract was. So when you combine these two things, you actually create a new entity which is called an operation state. An operation state has really just one operation. I think it should have a little bit more, but has really just one operation, which is start. So once you have an operation state, it's still inert. It just sits there and gets started when you call start on it. And start does whatever the sender is meant to do, and basically ranges for, well, once I'm completed, I call operations on the receiver. The contract, the fundamental contract for sender-receiver is, once you have connected the sender and the receiver, and you have called start, the operation state has to stay alive, it has to stay put, and the one of the completion signals, set value, set error, or set stop, gets called. The moment they get called, you can start deleting the operation state and everything is over. Having this guarantees allows you actually kind of to nest things and put them together. All right, so all that talk to go and say, well, what does it actually do? Well, this thing just puts things together. What it does next is, where is that code? Somewhere, I'm not entirely sure where the code sits. Okay, so state and state base would be some form of putting things together. So state base is basically a little bit of an abstract interface to which receivers, which when any creates, so when any will create one receiver for each of its operations. And basically the state base is the entity which these receivers talk to say, all right, I get data and we store this data in some shape or form, probably as a virtual functions, and eventually gets ready. And then inside, oh god, yeah, it's probably a little bit more complicated than one would want. There's some kind of notification of done. The important part is somewhere is the registering, basically, well, for all the senders it builds a receiver, gets a new operation state, it holds on to all these operation states. So when any state will have a list of internal operation states for each one of those, and each one completes. And now you only need to get all the types right and structure your code so that it compiles. Does that make some sense? No. Okay, that's fine. That's fine. It took me a while before I figured it out. If everybody understood it just from what I just blabbed, I would be impressed. So.
Nobody else has a question, then I have another one. Yeah, as we've seen, this is super powerful, but there's also a lot in terms of like concepts and machineries going on behind the scenes. What would be your recommendation if I want to start learning this? Where do I first look? How do I go about this? What's a good way to get started?
Okay, this is the annoying question. Like, all right, there's a bunch of people who understand that stuff. And surely one of these people have written a documentation. A few people have started, I know that. Nobody has the problem is the following. We all try to make the system as good as possible. And everybody who understands it goes kind of, oh, this is great. I want to make it better. They're all working on making it better. There's no documentation out there. This is literally a problem. Unfortunately, this is also kind of, if we had a documentation to get people on board, more people would understand and could help us. So we should really invest in getting people on board. If you really want to get into there, my personal recommendation would be to go on one of my dodgy GitHub repos. Let's see whether I get there. So this is the right repo. Colab, this is not in Beeman. There is inside the source directory is a directory which is called toy. This is too small, nobody can read that. Toy is it's basically a massively simplified sender-receiver implementation. It's simplified in the sense of instead of having variable number of arguments, set value always gets one argument, which basically removes half the template code you need. It doesn't do any of the customization stuff. It basically just goes, right, this is how you send a receiver operation states, and if you try to customize it, it's not going to work. This takes a bunch of things out. I think I ended up implementing some of the environment stuff, or the environment is not in a separate object, it's just sitting in a receiver, which is constraining but sufficient to channel along stop tokens and things like that. So this may be an easier way to get an idea without a lot of the craft to actually make it full-blown, fully generic, and have all the things in there. Yeah. And otherwise, there's a little bit of idea looking at things and trying to implement a sender. This is probably the most interesting stuff.